Welcome to the Explainer. I am so incredibly excited to have you here today. You know, if you've ever spent hours just staring at your screen, totally baffled as to why your JavaScript code is executing in a completely different order than you wrote it, well, you are in exactly the right place. Today, we're going to demystify one of the most fundamentally misunderstood concepts in web development, how JavaScript handles multiple tasks concurrently. We're breaking down the actual mechanics of the event loop, and then we'll see how modernizing your code with ES6 is literally the ultimate key to mastering it. We've got some fantastic, visually clear slides to guide us, so let's just jump right in.
Here's a quick look at our roadmap. We'll cover 1. The single-thread paradox, 2. Inside the event loop, 3. Microtasks versus macrotasks, 4. Avoiding common pitfalls, and finally, 5. Modernizing with ES6.
Okay, let's dive into this. Section 1. The single-thread paradox.
So, if JavaScript is single-threaded, how does it do so much at once? It's a completely valid question. JavaScript executes code synchronously in a single thread. In plain English, that means it can only process one single command at a time. It doesn't have multiple brains working on different problems simultaneously. So, if it can only do one thing at a time, how on earth does it handle fetching data from an API, responding to user clicks, and running timers, all without completely freezing your web page?
As you'll see here, we've got a pretty stark contrast. If you run a heavy piece of synchronous code, like an infinite while loop, it acts like a massive roadblock. It totally blocks the main thread. No UI updates, no clicks registered, the entire browser tab basically just freezes. But on the flip side, we have asynchronous operations. These let JavaScript initiate a task, like fetching data, and then just set it aside. It doesn't pause execution. It just keeps running the rest of your code while that fetch happens quietly in the background. But how does it keep track of what's happening in the background?
That brings us right to Section 2, inside the event loop.
Think of the event loop as the ultimate traffic manager for your code. Because JavaScript itself is single-threaded, it totally relies on this mechanism to manage the execution of multiple tasks without causing a massive traffic jam on the main thread. It's this continuous, never-ending loop that is constantly asking two questions. Is the main execution stack empty? And are there any tasks waiting in line to be executed?
And this builds into a functioning system through 4 specific steps. First up, we have the call stack. This manages your function execution in a strict LIFO order, last in, first out. When you run a function, it goes on the stack. When it finishes, it pops off. Step 2 involves web APIs. When your code hits a non-blocking operation, like a set timeout or a DOM event, the call stack essentially hands it off to the browser's web APIs to process in the background. Step 3. Once those background tasks are done, their callbacks don't just jump right back onto the call stack. Nope, they get pushed into task queues. And finally, step 4 is the event loop itself. The loop watches the call stack, and the exact moment that stack is completely empty, it grabs the first waiting callback from the queues and pushes it onto the stack for execution.
Moving on to Section 3, microtasks versus macrotasks. Now, what's really interesting about this priority breakdown is that we actually have 2 different lines waiting for the call stack. On top, we have the microtask queue. This queue has VIP high priority access. It handles things like promise callbacks, your .then, .catch, and .finally functions. The absolutely crucial rule here is that the event loop will fully drain the entire microtask queue before it even glances at anything else. Below that, we have the standard callback queue, often called the macrotask queue. This handles your set timeout, set interval, and DOM events. These guys only get to run when the call stack is empty and the microtask queue is completely clear.
To really drive this home, just look at this massive zero. Let's say you write a set timeout function and you give it a delay of exactly 0 milliseconds. Logically, you'd think it executes instantly, right? Well, actually wrong. Even with a 0 millisecond delay, it gets sent to the lower priority callback queue. If you have a promise resolve at the exact same time, that promise goes straight to the microtask queue. Because of those strict queue priorities, the event loop will always process that promise first, leaving your 0 delay timeout waiting in the dust. Understanding this exact priority order is literally what separates good developers from great ones.
All right, Section 4, avoiding common pitfalls.
The biggest nightmare here is callback how. You know the drill. When you have an asynchronous operation, that triggers another async operation, which triggers a third, and suddenly you're nesting callback function inside callback function inside callback function. Your code starts drifting all the way to the right side of the screen in this giant cascading pyramid shape. It becomes completely unreadable, highly prone to errors, and just an absolute misery to maintain or debug.
So to keep your applications running smoothly, here are the absolute best practices. First off, never block the main thread with heavy synchronous computations. Second, if you do have intense CPU tasks, optimize them. Use worker threads to get them off the main thread entirely. Third, use those high-priority microtasks wisely. Remember, the event loop drains the microtask queue completely. If you keep recursively adding microtasks, you're going to starve the macrotask queue, delaying other vital operations and potentially freezing up the UI. And finally, utilize performance tools. Things like Node.js performance hooks or Chrome DevTools are great to visually profile exactly how your event loop is behaving.
And that brings us to Section 5, Modernizing with ES6.
If you really want to fast-track your skills, courses like the SSDN Technologies 8-hour intensive are designed specifically to upgrade developers from outdated JavaScript to modern ESSDN Technologies 8-hour intensive are designed specifically to upgrade developers from outdated JavaScript to modern ESS6 or ES6. Modernizing your codebase is honestly the most actionable takeaway from this explainer, mostly because ES6 was fundamentally designed to solve the exact async problems we've been talking about.
Upgrading from ES5 to modern syntax isn't just about following the latest trends, It's about writing cleaner, far more predictable code. One of the first things you pick up in this modern curriculum is abandoning those outdated var declarations in favor of block-scoped, let, and const. You also move toward arrow functions. These give you cleaner syntax and, crucially, a much more predictable behavior for the this keyword, which used to cause just endless bugs in old callback functions.
The ES6 toolkit is incredibly vast, featuring some powerful tools you'd master in an upgrade course. You get destructuring and spread operators to handle data cleanly. You get native modules to really organize your files. But looking at those bottom two bullet points, this is where the magic really happens for the event loop. Promises and async await. These two features are the modern built-in cure for callback hell. Instead of nesting messy callbacks, promises let you chain operations cleanly, dropping straight into that high-priority microtask queue we talked about earlier.
This is where theory really meets practice. In Module 6 of the Intensive ES6 course, it's dedicated entirely to asynchronous programming. This is where you actually put the event loop mechanics into action. By mastering promises in depth and utilizing async await, you can write asynchronous, non-blocking code that actually reads just like synchronous top-to-bottom code. It makes managing those complex background API fetches and timers so elegant and highly maintainable.
So the event loop literally never stops. The real question is your ES6 code ready to keep up? We've unpacked how JavaScript manages concurrency through the call stack, web APIs, and those strictly prioritized task queues. We've also seen how sticking to old ES5 callbacks can sink your application straight into callback hell. But by upgrading your skills and fully leveraging modern ES6 features like promises and async await, you can work in perfect harmony with the event loop, building fast, responsive, and beautifully clean applications. Thank you so much for joining me on this explainer. Keep learning, keep optimizing, and I'll catch you on the next one.